Okay, so as promised, we keep moving up one level of difficulty. In the previous section, we talked about how we add and subtract polynomials, and the big deal there is finding like terms. So now let's look at how we multiply polynomials. So if you look at this multiplication problem, what you should believe is that it's a simple application of the distributive property, and we have to use our rules of multiplying exponents. And so when we multiply here through by 2x squared, we're going to get 6x to the power to the fifth minus 10x cubed plus 24x squared. Okay, so that's pretty simple. So let's step it up one level. So what we're multiplying here is one binomial by another binomial. Some of you may remember FOIL. Just kind of put that away for a second and think about what we're really doing. When you look at this problem, what we do is we take this 2x and we multiply it by each of these terms, and then we take minus 3y and multiply it by each of these terms. So what that gives us is 2x times 5x plus 2x times 2y plus minus 3y times 5x plus minus 3y times 2y. See how that works? So now I multiply things out, and I get 10x squared plus 4xy minus 15xy. Notice I always write those alphabetically. Minus 6y squared. Add the like terms. 10x squared minus 11xy minus 6y squared. And there you go. Okay, so let's remember what FOIL is all about. FOIL only works when you're multiplying two binomials. And FOIL is simply a reminder of the products that you're going to look at. So let's look at the same example that we just did. So FOIL tells us the F means multiply the first terms. The O means multiply the outside terms. I, inside terms. L, last terms. So it gives us a way of organizing all of these little products. So when I multiply the first terms, what I get is 10x squared. The outside terms give me 4xy. Inside terms, minus 15xy. And the last terms, minus 6y squared. And you should believe that this is exactly what we got before. It's just a little bit easier to organize that way. But please remember the importance of FOIL only when you're multiplying two binomials. Other than that, you need to use the rules of multiplication, generally the distributive property. And we'll look at an example about that next. Okay, so check this out. What we're multiplying here is a binomial times a trinomial. Can't use FOIL. And the way you work is similar to the way that we first looked at our product. You take the 2x, you kind of fix that, and you multiply 2x times each of these three terms. Then you go to the next term here, which is a 3, and you multiply each of these terms by the 3. And it looks like this. 2x times x squared, and then you have a minus 2x times 7x, and then you have a 2x times 4, and then you have a 3 times x squared, and then a minus 3 times 7x, and then you have a 3 times 4. So I multiply this all out, and I get 2x cubed minus 14x squared plus 8x plus 3x squared minus 21x plus 12. So at this point, what is it that you think you need to do next? Hopefully you said that you got to combine like terms. And so if I combine my like terms, when I look here, there's a 2x cubed and there aren't any other x cubed terms. So that stands alone. And then I look and I say, okay, here's an x squared and here's an x squared. So if I combine them, I have minus 11x squared. Look at the x terms. That's a minus 13x. And the plus 12 is the only constant. And so there you are. And so that's a more complicated version of how you multiply. And really it's all about the distributive property. All right, so in the next section we'll look at what are called some special products. But we're getting there. We're increasing our understanding and our knowledge of how polynomials work.